Hello, everyone. Welcome to this session, Clean Code to Make Uncle Bob Proud. This is for anyone who's struggling with a messy code base and trying to find the best practices to keep their code base clean. My name is Bhavna Singh. I'm a Salesforce MVP. I have my own consulting firm called 3 Moons Consulting. I'm also a Red Women coach and a Golden Hoodie winner. I've been writing code for a long time, and I'm still constantly learning how to write better code. There's always room for improvement. I'm going to turn off my camera so it's not distracting. So clean code, it feels like it's one of those things, unless someone points out, you might not understand why something is so hard to understand and how to make it easy. Long time ago, I went to a conference in Boston, and I happened to go to a session by Robert Martin. He's also known as Uncle Bob. I don't remember all the things he said that day, but one thing that still sticks in my memory and that I've been following ever since is he said, don't make your methods more than 5 lines long. Now, that's not a hard and fast rule, but that's something that has stuck in my head. I was dealing with some legacy code base at that time, and I remember this one particular method I was struggling with was 800 lines long. Can you imagine making sense of something that somebody else wrote that's 800 lines long? So I was struggling in understanding what that class was doing, and after attending Uncle Bob's session, I realized the reason I was struggling to understand what that class did was because the code wasn't following the best practices. Like Uncle Bob so eloquently says here, master programmers are great storytellers. And I wasn't sure about the story this code was telling. When someone has put in enough care in writing code, it shows. Clean code always looks like it was written by someone who cares. I always think of myself as a software craftsperson, and I want to take pride in my craft. So I do care. So why clean code? What's this big fuss all about? Why should we make an effort to write clean code? Bad code works too. If it's not broken, we should not try to fix it. So is it really necessary? Or is it just a personal preference? Why spend all that extra time making sure our code is clean and following the best practices? Most of the time, when you're asked to add a new feature to the code base, the estimates don't necessarily allow you to say, I ran into some bad code, I need to clean it up first. Often there's no time allocated for that. So do we even need to worry about having a clean code base? And how do we get to a messy code base? No one starts out writing bad code. So how does it become that? Let's walk through this scenario. You are in a brand new org, it has no code, and you write your first trigger. I have had an opportunity to do that a couple of times in the past couple of years, and it is the best feeling ever. You open Dev Console and there's no code, at least no code that's not a managed package. So you've been assigned to write this simple trigger, something as simple as maybe updating fields on a related object. It might take you an hour to do the whole thing, and pretty straightforward, pretty clean. Few weeks later, you need to make some more updates. No problem. Doesn't take you very long to add on the trigger. Now, everybody's getting excited about all this stuff happening so quickly. It feels like magic. So the requests start pouring in to add more things. You start adding to the same trigger. It is getting longer and longer. Now, business doesn't understand why you can't keep on delivering additional requests at the same pace as you did the first time. Things are getting long and cluttered, and you yourself are having trouble understanding and remembering what you did 6 months ago. So each additional request now takes longer and longer. And at this point, you are scared to add a line of code or remove a line of code or touch it because you're not quite sure of the impact of that change. So the system has become fragile and it breaks easily. Has anyone experienced code base like that? That is a tough situation to be in, and it is more common than you think. Now, on the flip side, imagine a perfect world. You have a clean code base. Things are small and modular. They're easy to understand. When you go back into your code, you can see at a glance what a method is doing, what a class is doing. You're able to make changes with confidence that you won't break anything, since your changes only impact a small portion of the code base. So your code is not fragile. It can handle changes and let you make changes fast. We can all dream, can't we? So what does a clean org that follows best practices look like? In a clean org's code, the code is easy to understand, not only to you who wrote it, but also by developers who didn't write it. It's easy to maintain by anyone, you or other developers. Modifications can be made without fear of breaking anything. And when you make one change, you're not introducing a side effect, a bad side effect, another bug. So clean code is simple, it's direct, it reads like a well-written prose. It's elegant, it's efficient, it's straightforward, and it makes it very difficult for bugs to hide. Okay, so that's all good. Clean code makes sense, but how do we begin? Where do we begin? We have this big, messy code base. It's overwhelming. So where do we begin? So the habit of writing clean code and following best practices would need to be cultivated over time. We can start out by at least being aware of some core principles, but we don't need to reinvent the wheel. There have been others before us who have also pondered such questions extensively and have come up with some guidelines. I would highly recommend a couple of books on this topic. I have added them to the resources slide at the end. So we'll understand the best practices. We'll commit to investing time for clean code, and we'll have our estimates allow time for clean code. And we'll go over this again later. So rule number 1, this is the rule that I remember from way back when. The number one thing I would recommend you focus on is to keep your methods short. Just like I heard from Uncle Bob a long time ago. He says rule number 1 is that your methods should be short. And then he says rule number 2 is that your methods should be shorter than that. I mean, it's funny, but it makes a point that keep your methods short. So look at this method. I apologize because this probably does not show very well on the screen, but I wanted to make a point of showing a method that is long and is doing multiple things. And this is not even that bad. I couldn't fit something that was 100 lines easily on a slide. If you look at this method, you can't really tell at a glance what it does. This is a before update method in a trigger, and it is doing multiple things. Suppose you have been assigned to add a new feature to before update, but you want to understand what it is already doing before you update. So like I said, imagine if this was a couple of 100 lines long, and that's not a very far-fetched scenario. I recently was asked to work on this trigger. So this it was, I believe, update, after update, or before update, and it was 500 lines long. And their tests were failing, and they had asked me to fix the failing test and improve the code coverage so they can deploy. I was really struggling to see what that code was doing, and it was hard for me to write tests before I could actually refactor the code. So keeping your methods short is the key. So here's the same code refactored. We can break out each functionality into its own method. So it could look like this. It has, so this part here is handle before update, same as this part here, handle before update. But now it's very short. And we can easily at a glance say what it's doing. Handle before update does these three things. It adds error for something, it handles audit field changes, and it sets category. And then if you need to drill down into each of that, you can see what each method is doing, which is also not very long and they are easy to understand. So this first method is looping through something and adding an error and calling a couple of things outside of here, another supporting methods to keep this method short. Similarly, the other three, all three methods are short and they're just doing one of the features from the big long method here. So this is one way of refactoring a long method and keeping your method short. Sometimes you might find a long method in your code that is doing multiple things and is accessing global variables. So it's got a lot of actions happening in the code and it's accessing global like class variables. What does that sound like? It sounds like a whole class. It sounds like there's a whole class hiding in a method. So when you identify something like that, consider refactoring that into a class of its own. I created this oversimplified method, example, because I just wanted to show nicely on the slides. So here we have a long method and it's using class attributes. We could refactor this whole method into a class. So this is the same code as before, but now as a class, it's broken into small methods that are easier to test. So the good thing about this is even though it looks like longer code, it's like you have a lot of small methods that can individually be tested. And this makes the code more robust and easily testable. Testable code is a whole other topic of discussion for another time. But yeah, this is better organized than this long method where everything is happening inside one method. So along the same line, another concept is that your methods, which Uncle Bob calls functions, should do one thing and they should do it well. So this method, as you see, was doing multiple things, and then we broke it down into methods that are only doing one thing. This one is getting contact, this one is getting unique IDs, so on and so forth. So they should only do one thing. So let's revisit the code sample from earlier. The handle before update method keeps the rule of keeping the method short by refactoring that whole long method into three methods that do one thing each. So in this case, the one thing that it does is what it needs to do before update. So whatever we need to handle before updating a record. So these things need to be kept together because these are all the things that need to happen before update. So they are actually one thing, but to keep the method short, we refactored it and we're just calling the other methods. Then if we revisit the other methods, the first method is also doing one thing. It's looping through new sales records and adding an error if certain condition happens. And then that condition is being determined in another method called audit box changed. Similarly, the second method is also looping through the new records, and if based on a flag, it's doing one thing or the other, which is also done separate in a separate method. And the third method also is also doing the one thing of setting a category, which is determined by a separate method in another class called sale business rule manager. This is really important, and I like to do this in my code, is try to keep all the business rules separate. So this, so suppose this thing changes later on, then we know this is one place where we are touching just the business rule and not rest of the trigger functionality. And we'll revisit this example again. So how do you know your method is doing one thing? One recommendation is you know it's doing one thing if you cannot meaningfully extract another function from it. So you refactor until you get to that state. I think there was some article saying refactor until you drop or something like that. So if we go back one slide and we look at the set category, it's really doing one thing because we cannot meaningfully refactor this into another method. literally doing one thing. So that's how you know it's doing one thing, because you can no longer refactor it. Another important concept to keep your code clean is to don't repeat yourself. This was coined by Andy Hunt and Dave Thomas in The Pragmatic Programmer, another wonderful book that is a must read for all developers. They just came out with an updated version after 20 years. I just bought this. This is really highly recommended read. So what does it mean to not repeat yourself? Let's look at some examples. So look at this code snippet. There seems to be business logic repeated in 2 places, and maybe it's in many more places in the code. So if a business rule changes, we need to find all the places we have where we have this code and then update it. And if we somehow fail to find one of the places, we will have to deal with unintended consequences. But what if we refactored it, the repeated logic, into a method of its own, and then call that method everywhere it's needed? So in this example, we're doing the same thing as before, but to avoid repetition, we just call one method called setCategory from both places. And then later on, like I said, if the business rule changes, we have only one place to change it. Like suppose the buckets of the amounts changes for different categories. We only have one place to change it. And this, this set category can be in a separate class, in a handler class, in a helper class. And if it's needed outside of the trigger, maybe it should be in a separate utility class or a business logic class. Another thing you might see repeated in the code is hard-coded strings and numbers. Let's look at this code. These are called magic strings or magic numbers. So this code on the left, we have hard-coded string purchase order multiple times. Maybe this is coming from a pick list value. And later on, somebody decided we don't want to call it purchase order, we just want to call it PO. So now we need to go back and find all the places to change this. And if we forget it in some places, we won't even get a syntax error because we're just comparing 2 strings, which is valid, and the code just won't work. And bugs like these are very hard to find, because what if you just had a small typo in one of the strings and you called it ORDR instead of ORDER? Very hard to find these kinds of bugs, because visually it looks, when you scan the code, it looks pretty same, and then the code doesn't work, and you can't understand why it's not going inside this if block. So to avoid this error, what you can do is you can create a constant and only have purchase order once. And then you use it everywhere. So that way, if somebody comes and changes purchase order to PO, you only have to change in one place. Pretty straightforward. Another example of repeated string. This is from a code I was working on too long ago. It was this old code that I had to revisit. So this was a controller for a Visualforce page. And so the date format was supposed to be, single. If it's a single digit day, then you just have that, and you don't have the leading 0. So that's fine, it worked. Then the client wanted to be consistent, and they wanted to have a leading 0 in front of it for formatting purposes or whatever. Something was not lining up on the Visualforce page. So they wanted a leading 0 in front of the single digit. So that meant I had to find all the instances and change them. And if I forgot one instance, it would not be an error because it's still a valid format. It would just be displaying the date inconsistently. So to fix that, I changed the code to work like this. I created a constant at the top of the class, and I used it everywhere. So it probably would have been better to also move this constant elsewhere, like a global definition, so that we use the same format across the board in all the controllers that you can refer everywhere, depending on what's needed in your business. So yeah, so this is another example of not having strings scattered all over your code, and use constants, so you're not repeating yourself. Let's talk about names. What is a name? Why is it important to worry about names? Why are they important? After all, like Shakespeare said, if we call Rose by any other name, it would still do its job. It would smell as sweet. So how does it matter if we call Rose R or XYZ or R12? Why is naming important? There's a famous paper written in 1997 called Ottinger's Rules for Variables and Class Names. I have included it in the resources. Please read and consult it often. Help decide how to name things. Names are not just for your convenience. They are a powerful communication tool. So choose them wisely and thoughtfully. So if we read that paper, there are some guidelines. For example, the class name should be nouns, and we should use verbs for method names because methods do things, right? They're some kind of action. They're usually either modifying something or calculating something or fetching something and returning it or saving something to the database. So there's action. So verbs can show action. So these are good guidelines. Let's see how naming and refactoring can help us read this if statement a little better. Something that might make it flow better and something that reads like a prose. So look at the example on the top. It's a bit hard to read. It's a bit cluttered up. It says if this condition and this condition and this condition, then get inside the if block and do that. So you can't really read it like a prose or English. But what if we remove all that clutter and we create a method? So we create a method that returns a Boolean because, as you know, the if statement, the inside should always be a Boolean. So we create a method, and now we have all of our conditions inside that method. It's almost like separating the business logic again. So if the account is annual revenue is greater than a number, active, billing state, and we can also in the future add more conditions here. It would not impact other code. And then if you look here, we call that method from the if statement. So now how does it read? So much better. It says if account is special, then assign to special team. That is so much easier to read than if all of this stuff. So this is a good way of refactoring the logic with Booleans to make it read better. Another suggestion, or maybe it should be a rule, maybe it should be a rule in your software standards, is to use intention revealing names. Please don't use XY123 and things like that. So here we have date D, which is fine. But then we have a comment to explain what date D is, opportunity close date. Okay, that's fine. Now consider we are down into the code and then we see something, some date plus D, and then we have to scroll back up and say, oh, what was D again? Oh, opportunity close date. And then later on, we're doing something else with the variable. And then we say, what was D again? We scroll back up and see, oh, D was the opportunity close date. So why not just name it what it is? We can name it opportunity close date. And then when later on we say we have another variable where we are reading, adding something or doing something, we know exactly what this opportunity, what this variable stands for. It stands for opportunity close date. So D does not tell you what its purpose is, but opportunity close date does. Also, use a name that can be pronounced. Like I was saying earlier, don't call Rose R2100 or whatever. So in this case, we have integer DTC, and then again, we need an comment. Looks like I have an extra slash there. Looks like, so we need a comment to explain what it is. Day is still closed. So, and also imagine if you're going through a code review and you're walking others through your code and you might need to read out the variable names, you would just have to say DTC over and over again. And it would be kind of hard to make it flow better. What if we just called it what it is, days till close? Don't abbreviate for brevity and just use enough words so anyone reading the code can understand, like it's like English is, a well-written prose. It just makes the code self-documenting, because the naming convention should tell you what it's doing. So self-documenting code, don't need extra comments. Another thing that I like to do often is I would sometimes add extra lines of code just so that it can read better. Look at the example in the top box. It says if something and something, and then something and something, then do, get inside the if block and do something. And that all of that clutter is kind of hard to understand what the condition is to go inside the if block. However, if I look at this code, looks like the first two conditions are basically looking in a trigger, the old and the new, and seeing if the old value was true and the new value was false. So it looks like it's checking for some checkbox. So call it a variable box was unchecked if this condition is true. And then the second condition says if the new record is active and status is open. So that can be combined into a variable called sale is active and open. So now if I read my if statement, it says if the box was unchecked and sale is active and open, then do something. So that's so much easier to read. It flows so much better. Does read like a prose. So the Clean Code book has this section about the Boy Scout rule. So it is not enough to write the code well. The code has to be kept clean over time. Otherwise, it will just degrade over time. So we can apply the Boy Scouts of America's simple rule to our code. If we all, anytime we touched a code, we left it cleaner than it was when we found it, then the code would eventually get better. Then cleanup won't end up being this big task. For example, you are working on a method and then you change one variable name for better, so it reads better. Or you see a method is too big, so maybe you break it into 2 or 3. Or you see duplication and you remove the duplication. And just imagine your code will simply get better over time. I think there's no other way of handling a messy org is just to, because I don't think we'll ever take the 6 months off where we clean the code. So one way of handling the messy code is every time you touch something, every time you create a new code, obviously follow all the best practices, but every time you touch any old code, then make sure you apply the best practices that you learned there. And I just wanted to revisit this one more time. I've mentioned it earlier in the example. If you find yourself excessively explaining through comments, maybe you need to rewrite it. Like it says here, don't comment bad code, just rewrite it. I feel like too much commenting can make the code harder to read. So as much as possible, use appropriate names to make the code self-documenting. And only add comments when you must clarify something that's not possible to explain using the name. So I wanted to briefly talk about my process that I always follow. So when I'm working on some new code, I just work. It's messy, I just get the code to work. So it'll be messy, long method, but at that point, I'm just wanting to get to work. Once it's working, then I go back and refactor it and clean it up and maybe change some names and then refactor it and then, the whole process. And that takes a while. Like how much time do you allocate for cleaning the code? Sometimes the same amount of time it took you to write the original code and sometimes even longer. But this is worth, investing in that. So build that in your estimate. And it'll get easier with time as you'll train your eyes to different patterns and different best practices that we talk about, it'll get faster. The first time you do it might take you a long time. You'll need to consult some documentation, but eventually it'll become a habit. And then a lot of things you will be able to just do it from the get-go, but the other things you can come back and refactor. So it will become easier, but build that into your estimates to write the code and then refactor it. So to summarize what we discussed today, follow these best practices. So the clean code rules: keep your methods short, don't repeat yourself, make sure your methods do just one thing, use good names, clear names, intention revealing names, pronounceable names, don't excessively comment to clarify, not to explain, and most importantly, leave everything better than you found it. This would help you keep your technical debt low to have the most efficient, nimble, and error-free code. And work with your development team and create some standards for your team, because there's no one set of standards that apply to all the teams. So among yourself, come up with something like naming conventions, indentations, white spaces. I mean, these things matter. If you have a team of developers and somebody is using 2 space, somebody's using 4 space, somebody's using a tab, it would matter. And curly braces, I'm not sure if you're aware of cuddled or not, but there's an article I included in the resources. But when you have these curly braces on the same line versus on the second line, if everybody's not following the same way, it makes the code confusing to read. So come up with these standards with your team, and then make sure they are followed. Accountability, you commit to keep the code clean, you came up with the standards, now hold code reviews and enforce those standards. Make sure everybody's following them. And it's so much easier to do it while you're working on the code than to go back and clean it. So during the code reviews, make those action items. Please change this to follow our standards. And I can't emphasize this enough. Your estimate should include time for clean code. And remember, you're not done when it works. You are done when it is clean. That's very important. So I like this quote, but I don't want to offend anybody by calling them a fool. So I want to read it like that. I didn't want to change it because that's what Martin Fowler said. But I read it as, anyone can write code that a computer can understand, but it takes a good programmer, with a lot of discipline to follow the rules we talked about today, to write code that humans can understand. These are some resources, some books that I really like, and some other articles that are, whenever you have time to read them. And I really want to thank you. I want to thank you for letting me share my thoughts. And please keep in touch as you start on this journey to clean code. And please reach out to me and see what you found useful and what you have done. And maybe you have some new ideas that I can follow. I'm active on Twitter and LinkedIn, so please reach out to me.